Hey everyone, welcome to The Explainer. Today, we're diving into something truly mind-blowing. We're going to unlock the enduring mystery and staggering genius of one of the most profound texts in human history. We are looking at a work so structurally perfect that it has literally shaped human logic for over 2 millennia. So get ready, because we're decoding the ultimate mathematical masterpiece, Euclid's Elements.
So I want you to really think about this for a second. How do you actually prove a universal truth? I don't mean something that just seems right most of the time or looks correct when you eyeball it. I mean an absolute, undeniable, bulletproof truth. How did humanity first figure out how to build those kinds of certainties from absolute scratch? Well, the answer is exactly what we're exploring today.
Okay, let's dive right into this. We're looking at a text that carries just massive historical weight. It's actually considered the world's oldest continuously used mathematical textbook. Just let that sink in. I mean, while empires have risen and fallen and technology has completely transformed our daily lives, the logic written on these pages, it's remained flawlessly intact and completely relevant.
This incredible document was put together way back around 300 BC in Alexandria. Now, the author, Euclid, didn't necessarily discover every single theorem in the book all by himself. Actually, what he did was gather the brilliant work of earlier Greek mathematicians, people like Pythagoras and Eudoxus, and he synthesized it all into one single, totally awe-inspiring logical masterpiece.
Here's our roadmap for today's explainer. First, the ultimate math textbook. Second, setting the ground rules. Third, constructing the truth. Fourth, the power of proof. And finally, the method of exhaustion. Let's get to it.
Section 1. The Ultimate Math Textbook. The Original Code.
Moving on to Section 2. Setting the ground rules. No rulers allowed.
So before Euclid even tries to prove a single theorem, he sets the stage, and he does it completely independent of any empirical measurement. No rulers, no protractors, nothing like that. Notice the incredible, almost poetic rigor of his vocabulary here. Take a look at definition 1. A point is that of which there is no part. Read out of thin air, he establishes the absolute fundamental, atomic bricks of geometry. From that single point, he builds the line, which is a length without breadth. And from there, he defines plane surfaces, right angles, circles. Basically, he's handing us the pieces to play the game.
Now, once we have those pieces, we obviously need rules. So Euclid gives us 5 postulates. These are the self-evident rules of the game that require absolutely zero proof. You can draw a straight line between any 2 points. You can extend that line continuously. You can draw a circle with any center and radius. All right angles are equal. And finally, the famous parallel postulate, which essentially locks us right into the geometry of flat space.
All right, Section 3, Constructing the Truth. Proposition 1.
This is where things get really fun. This is where we take those simple pieces and rules and use them to prove something entirely new. Proposition 1 asks us to construct an equilateral triangle on a given finite straight line. So visually trace that horizontal line right there in the middle. Straight line AB. That is our starting point. Literally nothing else exists yet.
Following Euclid's rules, here are our building block steps. First, using postulate 3, we draw a circle with its center at point A and a radius that reaches all the way to point B. That gives us circle BCD. Next, we do the exact same thing from the other side. We draw a circle with its center at B and a radius reaching back to point A, and that's circle ACE. Finally, using postulate 1, we draw straight lines from where those 2 circles intersect at point C, straight down to point A, and straight down to point B.
And there we have it. The completed construction forming triangle ABC right there in that intersection. Now, visually, yeah, it certainly looks like an equilateral triangle, but looking right just isn't good enough for Euclid. So here is the really crucial question. How do we absolutely know without a shadow of a doubt that these 3 lines, AB, CA, and CB, are perfectly equal?
Well, the aha moment is found right here in Euclid's Common Notion 1. It states, things equal to the same thing are also equal to one another. Just think about that. Because point A is the center of the first circle, line CA is equal to the radius AB. And because point B is the center of the second circle, line CB is also equal to the radius AB. Therefore, since CA and CB are both equal to AB, they simply must be equal to each other. The triangle is perfectly, undeniably equilateral. Boom. Truth constructed.
Section 4. The Power of Proof. Building Complexity. What we just did there was actually monumental, because Proposition 1 now becomes a brand new foundational brick, and this brilliantly illustrates how the logic scales up in Proposition 4, which you might know as the side-angle-side congruence. Euclid proves that if two triangles have two sides in the enclosed angle equal, the entire triangles are exactly equal. But how? Well, he mentally superimposes one triangle ABC directly over the other one, DEF. If point A is placed on D and line AB on DE, the whole shape is basically forced to perfectly coincide. He proves them mathematically identical without ever touching a measuring tape.
This really highlights a massive leap in human thought. It's the ultimate contrast between just eyeballing shapes versus true geometric proof. You see, empirical measurement is inherently flawed, right? Rulers warp, human eyes make mistakes, even pencils have thickness. But Euclid's flawless method exists purely in the realm of the mind. By strictly applying figures to one another logically so their bases and angles match perfectly, he achieves absolute certainty.
And finally, Section 5, the method of exhaustion, ancient calculus.
Okay, let's zoom out a bit. We've really only looked at the very beginning, but the sheer macro view of this text is staggering. Just take a look at the massive scope mapped out across all 13 books. We start out with plane geometry in Book 1. By Book 7, he's defining prime numbers and elementary number theory. In Books 10 and 12, he utilizes this thing called the method of exhaustion. It's this ancient, mind-blowing precursor to modern calculus and integration, and it allowed him to precisely calculate the relative volumes of 3D objects like cones, cylinders, and spheres. And the whole thing culminates in Book 13 with the mathematics of the Platonic solids. It is literally a towering skyscraper of logic, and the whole shebang is built on just a handful of simple rules. So what you should really take away from all this is the profound power of the axiomatic method. This core idea that you can start with simple, self-evident truths and rigorously deduce incredibly complex realities from them, that is the ultimate foundation of modern scientific thought. It is the logical architecture behind computer programming, modern physics, rational philosophy, you name it. Euclid didn't just teach humanity what to think about space, he taught us exactly how to think critically.
Which leaves us with one final, deeply fascinating question to ponder. If the staggeringly complex mathematical truths of our universe are ultimately built on a few simple, inherently unprovable postulates, what are the foundational postulates of your own reality? What are the unquestioned rules you base your life on? It's definitely something to think about. Thanks so much for joining me for this explainer, and keep questioning the foundations.